So we've just gone through what an ionic compound is, something that's made up of a cation and an anion. And we had a nice easy one, sodium hydroxide, to learn that, where the sodium had a +1 charge and the hydroxide had a -1 charge. So it's just one sodium ion for every one hydroxide ion. That's their ratio, 1:1. What happens though when you get something like magnesium, which is 2+, and chloride, which is 1-? An ionic compound needs to be electrically neutral. It means that the number of positive charges has to equal the number of negative charges. At the moment, I've got 2 pluses and 1-. So I need an extra chloride in there. So this will be in what we call a 2:1 ratio, 2 chlorides for every 1 magnesium. So magnesium chloride, and there's our name saying our cation first. Magnesium chloride has got 2 chlorides in it. So when we have multiples of things in a chemical formula, which is what we're trying to write, we use little subscripts or little numbers down the bottom to represent that. So there's only 1 magnesium, so it doesn't need a number next to it, because Mg means 1 magnesium ion. We've got 2 chlorides, so I write my Cl, and the 2 goes down here. So I've got 2 of the thing that comes before it. 2 negative charges, 2 positive charges, electrically neutral, this substance can exist as magnesium chloride. It gets a little bit trickier when one of our ions has got more than one type of atom in it. It's what we call polyatomic. So if I'm going to stick with magnesium because we've met it, and I'm going to use hydroxide because we've met that. If we had magnesium hydroxide, and I write those down, so magnesium doesn't change as an ion, it's always Mg2+. And hydroxide we met before is OH-. Because it's only 1 negative, I need 2 of them. When I write this, it will look something like this. This is not completely correct what I'm about to write. MgOH2. Now the problem with writing MgOH2, the 2 only applies to what's directly before it. So we need to group the O and the H together. Just like we group things in maths, we use brackets. That keeps that together as one thing. Now this means 2 hydroxides, not just 2 hydrogens. So to give you a comparison for that, the carbonate ion has only got 3 oxygens and 1 carbon. So it only talks about the one directly before it. If it was 3 COs, I'd have to put a bracket around the C and the O. Now, drawing these out like this gets a bit tedious and a little bit hard to do in an exam. So luckily we've got a trick for how to do it, and it's called drop and swap. And I'm going to use my magnesium hydroxide as my example for that. When I write the ion charges out, I have Mg2+ and OH negative. If the numbers don't match, that's the first key step. If the numbers don't match, if this was a 2-, you don't use drop and swap. They just go together. If they don't match, then I take any of the numbers and I drop them, and then I swap them to the other one. Because the hydroxide doesn't have a number, I don't do that with hydroxide. I know it's got a negative charge, but that's not a number. There's no number in front of it. So I end up with MgOH2, like I did before. And then again, if any of them got more than 1 atom in them, we put in our brackets. So my next example I'm going to use is something that's got numbers for both of them. And this will be my last one for this video. So if I've got iron 3, which is one of the ions we've been asked to learn, and oxide, another ion we've been asked to learn, The 3 and the 2 are different numbers. So I drop and swap my 3, and I drop and swap my 2. So I end up with Fe2O3 as my formula for this ionic compound. So the key idea is the charges have to cancel out. When you've got multiples of things, you use little numbers. If the ion is made up of more than one atom, more than one type of atom, you need to use brackets. If you want a quick way to do this in an exam, you use drop and swap. The reason drop and swap works is it cancels the charges out. 3 negative 2 is negative 6. 2 times positive 3 is positive 6. And that's why that works. So you can't use drop and swap as your reason in an exam. The reason is to cancel the charges out. So the charges of the 2 ions cancel out. Drop and swap is how you do it. It's the method.